Decision trees help AI make step-by-step business decisions by splitting data into simple choices that lead to clear predictions. Now let's look at a decision tree works like a flowchart. A decision tree is one of the easiest machine learning models to understand. It works like a flowchart. The model asks a series of questions. Each answer moves the data to the next branch. At the end, the tree reaches a prediction or decision. This makes decision trees useful when people need explainable AI. You can often see why the model made a decision. Now let's look at what you will learn. First, we will understand what a decision tree is. Then we will learn why decision trees are used in machine learning. Next, we will explain root nodes, branches, decision nodes, and leaf nodes. After that, we will compare classification and regression trees. Then we will see how decision trees split data. Finally, we will use business examples and review common beginner mistakes. Now let's look at what is a decision tree. A decision tree is a supervised learning algorithm. Supervised learning means it learns from examples with known answers. It can be used for classification and regression. Classification predicts a category. Regression predicts a number. The tree learns rules from historical data. Then it applies those rules to new data. Now let's look at why decision trees are used. Decision trees are popular because they are easy to explain. Many models behave like a black box. A decision tree shows a clear path from input to prediction. This is useful for business teams. It helps analysts explain decisions to managers, auditors, and process owners. Decision trees also work with many types of business problems. They are practical for both learning and real-world decision support. Now let's look at root node, branch, and leaf node. The root node is the first question in the tree. A decision node is a point where another question is asked. A branch is the path created by an answer. A leaf node is the final prediction. For example, the root question may be, has the customer complained recently? The branch may be yes or no. The leaf may predict churn risk. Now let's look at a simple customer churn tree. Imagine a business wants to predict customer churn. The first question may be, has usage dropped? If yes, the next question may be, did the customer complain? If yes again, the tree may predict high churn risk. If usage has not dropped, the tree may predict low churn risk. This is how a tree turns business logic into prediction paths. Each path is easy to follow. Now let's look at classification trees. A classification tree predicts a category. Examples include churn or no churn, fraud or not fraud, approved or rejected, high risk or low risk. The tree asks questions that separate data into classes. At the final leaf node, it gives the predicted class. This is useful when business decisions are category-based. Now let's look at regression trees. A regression tree predicts a number. Examples include sales, price, cost, delivery time, or demand. The tree still asks questions and splits data. But the final answer is a numerical value. For example, a sales tree may predict next month's sales. A logistics tree may predict delivery time. Regression trees are useful for forecasting and estimation. Now let's look at how decision trees split data. A decision tree learns by splitting data into smaller groups. It chooses questions that separate the data better. For classification, it tries to create groups that are mostly one class. For regression, it tries to create groups with similar numerical values. The goal is to make each split more useful. Good splits make the final prediction more accurate. Poor splits create confusion and weak predictions. Now let's look at splitting example, loan approval. Imagine a bank wants to classify loan applications. The tree may first check credit score. Then it may check income. Then it may check existing debt. Finally, it may predict approve, reject, or review. The tree does not just memorize decisions. It learns patterns from past loan outcomes. Now let's look at business example, customer churn. Customer churn prediction is a common decision tree use case. Features may include usage drop, complaints, payment delays, tenure, and support tickets. The tree creates decision paths based on these features. High-risk customers can receive retention offers. Medium-risk customers can receive support outreach. Low-risk customers may need no immediate action. This helps teams prioritize customer retention. Now let's look at business example, loan and risk. Decision trees can help classify loan and credit risk. Features may include credit score, income, debt, repayment history, and employment status. The tree can predict low risk, medium risk, or high risk. It can also recommend manual review for unclear cases. This makes risk decisions easier to explain. But financial decisions need governance and human review. Explainability does not remove responsibility. Now let's look at business example, fraud detection. Fraud detection is another common classification problem. A tree may check transaction amount, location, time, device, and customer behavior. Unusual combinations may lead to higher fraud risk. Simple fraud cases may be flagged quickly. Borderline cases may go for manual review. Decision trees can create understandable fraud rules. This helps fraud teams investigate suspicious activity. Now let's look at business example, healthcare triage. Decision trees can support healthcare triage. The tree may ask questions about symptoms, age, test results, and medical history. It can help identify low, medium, or high-risk cases. This can support prioritization. But healthcare predictions must be handled carefully. A decision tree should support doctors, not replace them. Human clinical judgment remains essential. Now let's look at business example, manufacturing quality. In manufacturing, decision trees can help with quality checks. Features may include temperature, pressure, vibration, speed, and inspection readings. The tree can predict pass, fail, or review. It may also help identify why a defect happened. This supports faster root cause analysis. It can reduce waste and improve quality control. The clear decision path is useful for operations teams. Now let's look at advantages of decision trees. Decision trees are easy to understand. They can handle both classification and regression. They can work with numerical and categorical features. They show the logic behind a prediction. They are useful for business communication. They can capture nonlinear patterns. They are a strong beginner model for learning machine learning. Now let's look at limitations of decision trees. Decision trees can overfit the training data. Overfitting means the tree learns too much detail from old data. It may perform well on training data but badly on new data. Large trees can become hard to read. Small changes in data can sometimes create different trees. Decision trees may need pruning or depth limits. That is why testing and validation are important. Now let's look at common beginner mistakes. One mistake is building a tree that is too deep. Another is judging the model only on training accuracy. Beginners may ignore missing values and outliers. They may also forget to split data into training and testing sets. Another mistake is assuming an explainable model is always correct. A clear tree can still make wrong predictions. Always evaluate performance before using it in business decisions. Now let's look at when should you use a decision tree? Use a decision tree when explainability matters. Use it when you want a clear prediction path. Use it for classification or regression problems. Use it when business users need to understand the model. It is also useful as a baseline model. If performance is weak, you can later try random forest or gradient boosting. Start simple, then improve step by step. Now let's look at final content recap. A decision tree is a supervised machine learning model. It works like a flowchart of questions and answers. The root node starts the tree. Branches represent paths. Leaf nodes give final predictions. Decision trees can solve classification and regression problems. They are useful in churn, loans, fraud, healthcare, sales, and manufacturing. Their biggest strength is explainability, but they still need careful testing. To wrap up, here is the key takeaway. You now have a structured overview of decision tree and machine learning explained business examples. Review the core ideas, connect them to examples, and revisit concepts like a decision tree works like a flowchart. What you will learn: what is a decision tree? When practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.